Welcome to Chapter 3. Today we'll learn about a new technique, RAG, which is a Retrieval Augmented Generation. This is a very popular technique used in the LLM, generative AI. So till now we learned in the chapter 2. Chapter 2 what we learned that user makes a query, it reaches to a service, user facing service, and that service goes to LLM and generates the answer, serve it back to the user. This is the traditional LLM call, and that's what we learned in the chapter 2. Now what is LLM actually? Let's look a bit about LLM, large language model. It is a multiverse model, multiverse visualized in the multiverse domain, that it works on prediction. And what type of models are like? Whenever there is a model is generated or created, it is pre-trained. It has given a training means it has given a knowledge, like a class 10th or 12th kid kind of, means it knows the all the language like Hindi, English and different languages, and knows the basic reasoning. And then after, there are fine-tuned models which is given extra knowledge like engineering, MBBS, lawyer, mathematician. Those all information uh, is taught to the model, and then that model is called as a fine-tuned model. Based on the use case, anyone can have a particular, they can do a training, means if say suppose you have a use case, and what you can do, you can pick a pre-trained model and train it for your particular data sets. That can be a custom solution, but hosting a model adds an extra cost. So what ideally people do, they choose a already hosted model, say a GPT model, which we already have a free account. So those general purpose models, they are trained on multiple or like all public data, like they are doctor, they are engineer, they are lawyer, they are mathematician, they are trained on all those domains. So we are using such public models. Now we'll not talk about how those learning happens, but we'll come down like on a keyword. Like I told, these models are trained on all public data, public knowledge. So now this public knowledge, now come to your particular use case. Say suppose you have a data set which is private to your organization. Now since it is a private to your organization, a public model cannot give an answer uh, if there is a question which is supposed to be answered from that private knowledge. A public model cannot give that answer. Now how to solve that problem? So that's the one problem. Another problem is public model is trained on a cutoff date. So say suppose there is a model which is created in Jan 24, which is made live in Jan 24. That means it may have a knowledge until Jan 24. Now we are already in 25. So it is already 1.5 year old knowledge base. It is trained on a 1.5 year old knowledge base. Now even though uh, and then this is also a challenging thing to change the model. Now say suppose you write an application, and you cannot go in each 6 months and change the model. That's an extra work. Now how to solve that problem? Now to solve that problem, RAG is very useful technique. What it is, retrieval augmented generation is a technique that enables the capability of large language model by combining them with an information retrieval system. Let's learn it in the layman term. Let's see first how it works. So say suppose, so like if I compare with the previous sequence, the query was reaching to the service was giving the query to the LLM and serving back the answer. If the LLM has the information, it gives the answer. If it doesn't have the information, it fails to answer the user query. Now let's come to the using RAG. Using RAG, what happens? User query, so the service, it first go to RAG with the user query. Now we will learn it from a basic example. You have a big book, Say suppose it's a science book which has 1,000 pages. Now, when user query comes, user query ideally will be talking about, or it query will be having an, so user query has the answer on the page number 100. Now, you cannot give all 1,000 page to a LLM model and tell the model to answer the user query from these 1,000 pages. That's a too much context for a model. So the model has the context limit, 1 million token, something like that. So not 1 million, sorry, 32K kind of. So that's a very big limit is very big, but 1,000 pages are even more. And to solve that problem, RAG plays a very good role. What happens in the RAG techniques, the whole 1,000 pages are broken into the small pieces. You can say like the paragraphs, and those paragraphs are used to generate the vector embeddings, which is kind of a numeric value. Those vector embeddings saved into the vector database. Now, when user query comes, it hits the vector database and gets that particular paragraphs which is related to the user query. So say suppose answer for the user query is available on the page number 100. The RAG query will return me the the information written on the page number 100. Now the service can go to LLM with the user query and the page number 100 knowledge, means augmented with the RAG knowledge. In this case, LLM will be able to generate the final answer very neatly. So this is what is the RAG. Let's see this whole things in action, how we write the code for these things. So to do that, you remember for LLM interface in the chapter 2, we already used the OpenAI key. We created the OpenAI free account, used the OpenAI key to generate the answer. So this is what we already done in the chapter 2. Now we will include it, we will add the embeddings, vector embeddings, the RAG part of the LLM query, and we see how it works. So now to generate the embeddings, we can either use the OpenAI model itself, but since we are on the free tier, this OpenAI model is not available to us. We have to, or you have to add the balance. So for making it again free to use, since we are on the learning module, so keep it free, I'm gonna use the sentence transformer. So sentence transformer with the model all-many L6V2. This will generate the vector embeddings for me. So I'm gonna feed this sentence transformer. I'm gonna create the ChromaDB object, which is a vector database locally hosted. This is the file been created already here. I have already created the embedding. So for testing, I have added a insurance copy, my insurance copy, and this has few data. Let me just show you. You can see this is the insurance copy. This has all my insurance information. This is for testing. I am adding this PDF in the embedding. So I have created the chroma object with the embedding function. Embedding function is nothing but the sentence transformer. Then we have a generate embeddings, and under the generate embeddings, I'm getting the records to injects. Records to injects is nothing but it will get the text from the PDF file. Will do a corrected text splitter. This is nothing but will split the text into the small pieces, like I told, the big book into the paragraphs kind of. So those splitted text blocks, now we will go back and we'll do a save embeddings. So part of the same embeddings, internally this ChromaDB will call the functions. What is those functions? Embed document. So I have just create a wrapper file here, which internally will call the model dot encode. So one embed document for creating the embeddings, another one the embed query, because when the user query comes, that also we need to create the embeddings to do the vector comparison. to find the cosine similarities between those two vector values. So this is how. So I have already run this. Um, Now I have created a Streamlit file to test these things. So for Streamlit, let me first show you how the RAG works. So this is the RAG interface. I have also have the LLM interface. I can do a RAG search and I'll get the context here. So I'll comment these two lines for now. So instead of answer, I'll fill the context here to see, to show you how it works. I'll pick this to run the Streamlit. So we have this. I'm on a very basic system. It's i3 laptop. So you can see things are a bit slow. Meanwhile, it loads. I'll just show you. This is the sentence transformer library. So I have already added into the requirement.txt. You just need to rerun the pip install requirement.txt. It will automatically install. First time when you will do this embeddings run, to create the embeddings, it will load the sentence transformer in memory. So it will take a while, depend upon your laptop speed. So no need to worry. So all calculation will happen on your local machine only. So now here I'll ask the what is IDV value. So this question will go to the rack query, means my this query will be converted into the vector embeddings, and then there will be a vector comparison, cosine similarity comparison inside the vector dv, and that value will be printed back here. Let us see how what is happening. Okay, so result is here. You can see the whole pdf is already divided. Now this particular block is pulled up, which has the idv data. You can see there are taylor idv values, some data is there. So this is the knowledge. So RAG helped here to pull that particular block of information, which can be used to answer the user query. Now let us connect with the LLM things to see how it fully works in end-to-end application. So now I have a RAG. I got the knowledge which can answer the user's question. Then I can have LLM interface, can ask the question and the knowledge. So I'll ask the LLM with the context, and this answer I'll to print in the UI. So let's see how this will work. What is the IDV value? This time it will do RAG query as well as will go to the LLM to generate the final answer. You can see how it is happening. So RAG query already done, response also came, getting printed. Yeah. So now the answer is tailored to the exact user question. So this is what is that's what all the magic happened. If you want, we can see this LLM interface file. So this is the function we called ask LLM with context, which has the question and the context. Context is nothing but, so here is the final prompt how we have built. Answer user question using the provided context as knowledge. So you also need to learn how to write the prompts. So this is very basic prompt. You can give more guidance here, like answer the question only when the query is related to your company. Answer, do not answer the question if it doesn't follow these particular criteria. So those all things you can add into your prompt. This is a very basic prompt. Answer question using the provided context and knowledge. Here is the question and here is the context. So this is the basic, very basic prompt I have written here. That's it.